Hello all and welcome back. So in this video, let us now move forward and try to solve this question using memoization. We have solved the min cost path question in the last video using recursion. I'm pretty sure that all of you must have tried both the approaches and the same will be a lot clear to you. So now let's move forward and see should we apply memoization here or not. Okay. So again, the basic idea is the same for DP, right? For us to apply DP, we have to first see if there are multiple sub problems which we are solving again and again, right? So if we talk about this particular problem in which we are solving, we normally start from 2 comma 2. Okay. And if we go back to our code, we used to make call like this: m and n minus 1, then m minus 1 and then m minus 1, n minus 1. Okay. So effectively, that means at each and every position, I am making three calls: 2 comma 1, 1 comma 2, and 1 comma 1. Okay. So these are the three places, or you can say sub problems, on which my answer depends. Now this 2 comma 1, it's also going to make the same calls. So it's going to be 2 comma 0. Then we will have 1 comma 1 and 1 comma 0, right? Similarly, this 1 by 2 space, so let me draw it as well here. So this is the exact position where we are. Now this depends on these three boxes or these three sub problems, right everyone? Now this 2 comma 1, okay? So let me write down the indexes. 2 comma 1 is this box. If we see, this particular will depend on these three problems, right? So the first is 2 comma 0, which is this one. Then next is 1 comma 1, which is this one. And then we have 1 comma 0. Okay. So pretty sure that you are able to understand each and every one of them. Now, similarly, this 1 comma 2, this particular box will depend on these three problems. Okay. So let us write that down. We will have first one where we are subtracting the negative. Then we will have 0 comma 2 and finally subtracting both of them. Okay. So great everyone. I hope you're able to see this. Now, when I am standing on this 1 comma 2, this is 1 comma 2. In this is getting dependent on first 1 comma 1, which is this one, which is left. Now this is top, if you will see, 0 comma 2, and last is diagonal. Okay. In a similar manner, let us write for 1 comma 1. This 1 comma 1 will depend on these three boxes. Okay. So it will be 1 comma 0, 0 comma 1, and finally 0 comma 0. So this overall box depends on 1 comma 0, which is this one. Then it depends on this one, which is 0 comma 1, and finally 0 comma 0. Okay, great. So let us see, do we have some sub problems here which are overlapping? I think we have. So if you will see here, this is the same problem, 1 comma 1 and 1 comma 1. Okay. Then similarly, we have 0 comma 1 here, 0 comma 1 here. Okay, 1 comma 0 is here, 1 comma 0 is here. Okay, so I hope you get the idea that there are sub problems which we are solving again and again. That's a very good case of applying dynamic programming, something which we have discussed in the first class, that dynamic programming can be applied to cases like this, right everyone? Now, if we think about this, here we have a 2D space. Here we are dealing with a particular 2D space or 2D matrix. Now, it will be a lot better if I can make a memoization array or a list which is 2D in nature. So let us move forward and see how we will be doing that. Now, I will be making a list of 2D space. 1 minute. So we will have something like this. This will be my memoization space or memoization list, right? Now, one thing to always and always remember in these kind of questions, normally we say them as 2D DP because now we have a 2D space to overall handle or see, right? So in 2D DP, okay, or rather in DP as well, we have to always make sure that we are clearing out few things. The first is the space. We have made that space or list size. Okay. Second, if we see, it's actually what each box signifies. What does this mean? So let's say these are my indexes 0, 1, 2. What does this specifically 1 comma 1 box means? It is very important to specify this thing if or when you are solving a question in DP. In 1D DP, it was pretty straightforward. For Fibonacci, we were saying that for I is equals to, let's say, 5, it is the fifth Fibonacci number, right? Now, in a way, if you think we saw in the tree as well, these are just all the sub problems, right, everyone? So these are just all the sub problems which are of the same nature. That is why I was able to call recursion here, right? So what does, like, if we go back to our basics, recursion, we learned that it is, yes, it is a function calling itself in terms of application, but the basic idea was not that. Basic idea was that if a problem depends on similar smaller problem. So all I'm saying is that, hey, I will get you the 2 comma 2 minimum cost if you give me the minimum cost from these overall problems, right? What does that mean? What does that transforms to is basically that each and every of these boxes give the answer to our sub problem. That is minimum cost path from 0 comma 0 to this box or vice versa, because the cost is going to be the same. If you are taking a minimum path from A to B, then that path will there be from B to A. Okay, great. So I hope this thing is clear. Again, it is very, very important. We have to always make sure to specify that what each and every box or each and every location or space signify. After that only we can just move forward. Okay, great. Now, if I have to find the minimum cost to reach at this position, okay, and I have the minimum cost 1, minimum cost 2, and minimum cost 3, then I think I can just take minimum of C1, C2, and C3 and add whatever cost I have. So cost m comma n. Okay, so I will repeat this understanding again. Because at this 1, 2, and 3 box, I have the minimum cost which will be there from 0, 0 to this particular position, or from this position to 0, comma 0. I can just take their minimum and add the cost, okay, where I am standing. So let me just write it clearly. Cost m comma n. Okay, everyone. So pretty sure that this thing is now a lot clear. So idea is that I will be making this 2D list. Okay, we'll be calling that memoization array or list, right? And in each and every box, along with calculating the answer, I will save the same as well. Okay. If I am saving that, then of course we don't need to calculate or solve our problem again and again. And that is just the basic idea. Okay. We have seen in DP how that will help us to save the time. Now we can see this thing once. A couple of things. Here, this time complexity is of the order 3 to the power n, because we are calling on each and every from each and every location in three directions, right? So each and every tree is having three children, one, two, three, then one, two, three. Okay. Along with that, we can be sure of one more thing, that is m cross n will be size of our memo list. The reason is same, because I have m cross n spaces or boxes or subproblems which I am solving. It's just that I'm solving them again and again in recursion, so that's why it's taking a lot of time. So I'm pretty sure that everyone now this will be a lot more clear that what exactly is happening here, right? And that is what is very important to understand in 2D DP. So I will repeat the steps and I will write them down as well so that we are 100% clear. Let me add a page and let us see the steps which are there in 2D DP. Steps for solving 2D DP using memoization. These are all practical based steps. You can find some big or I would say long list of steps in some website or something. But I think the things which you learn via practical, that are the one which you actually understand. Okay. And it is not some exam where you have to write them down. It's majorly for you to remember. Okay. So please make sure that you always understand these things by your own experience rather than following any, I would say, tutorial or some long list of this. Okay. First, solve problem using recursion. That will surely be there. Okay. Second, exactly what we did. Create recursion tree and see if sub problems are overlapping. Okay. So that's the second part, everyone. Third, find out unique subproblems. Once we have the unique subproblems, we will have an idea that okay, what should be our dimensions majorly of our memoization array. Fourth, create the memo space. Okay, so it can be a 2D list, it can be a 1D list. Like again, these are the basic steps which we are following till now. Fifth, which is very important, define what each box or individual memory in space signify. This step is very important. We have to make sure that we are clear on what exactly each and every of this space, individual space or box in our whole memoization array or list signify. Okay. Because based on that only I will be able to say that, hey, I have this particular thing. Now, based on this, I can write my logic. Okay. Sixth, write down code and save the solution. Okay, so pretty sure now it will be a lot more clear, everyone, what exactly we have to do. So if this is clear, then let us move forward and try to code this down. I'm pretty sure that it will be a lot more clear when we code it. Okay, so let me just close this one and let us write min cost path memoization. Cost m n and a memo space will be passed. Now we can create a memo space, okay, memoization array, something like this. So we were creating as of now using this code, right? For I in range, we can say n plus 1, let's say it's m and n, right? So let us say this. We want a space here which is equivalent to m cross n. Okay, so n is the number of columns and n is the number of rows. So once I have this space, I can just further call my, let me just make sure 1 minute. Yeah. Now this space is there. I'm using list comprehension here. Pretty sure all of you must have used that. So once I have this array, 1D array, okay, 1D list, I just want it for m times more. Okay, so this is the rows and these are the columns. First, I will create a single row and then I will just copy that row m times. I am taking m plus 1 for, of course, a easy overall use. Okay, everyone. So I hope this is clear now. Let us now try to write down the code and see how exactly things will happen. Great. So first will be the base case. Okay. If m0 and n0, we can just say that, hey, you are on the starting point. That is the cost. Okay. You can think of this as a single cost matrix as well. Okay. Something like this. If you are on 0 and you want to reach on 0, that's the cost. Great. Next is our out of bounds error, right? So out of bounds. What we used to do here, everyone, if m less than 0 and n less than 0, not and again, or we used to return float of our infinity. Okay, pretty sure that this must also be clear. Once this is done, I have to check if I have previously solved my problem. So for that, we can just write this condition. If this is not equal to -1, then I can say that, okay, return whatever is here, because that signifies that I have solved my problem. Great. After that, I will have to make these recursive calls. So that is going to be the same. We have to still make these recursive calls. Now I cannot store these recursive call in m and n minus 1 because these are not the answers. Okay, these are just the recursive calls for getting the cost. Once I get my answer, something which we wrote like this. Okay, so cost of m comma n plus minimum of cost left, cost top, cost diagonal. Once I do this and I return the answer, I have to just make sure that I am saving this answer as well. Equals answer. Okay, so pretty straightforward code. Just exactly we did in the last video using recursion. Just that this time I have used a memoization array to store my answer. And because it is in 2D space, we just have to make sure that we do few things. Okay, great. So let me run this now, everyone. 1 minute. So again, we will have to just make sure we call this here and pass the memoization array. It's normally a good practice to pass this memoization space or array, right? We can, of course, all of you might be thinking that yes, we can declare it globally as well. But normally it's a very good practice if we are defining it and passing it with each function. Because if let's say some changes are happening, okay, we can make sure that it is getting passed and everything is happening there only. Okay, great. So we have to just call this memoization and memo will be there. Okay, so what we can do, I think it is giving us the answer, but something which we can do here is we can print our memo array as well. So if we will see here what exactly this memo array is becoming, let us see this. So let's say for row in memo, let us print this row. Okay, print row. Okay, print. See, so here it is -1. Okay, because we are starting from here, this is the base case, so it is not getting updated. Ideally, we can even make sure that we do this as well. We can update this as well. Now, if you will see, this is 8 here because this is the answer. If I start from here and go all the way till here, this is what I should get. What this is the minimum cost. This 10 is actually the minimum cost if I start from this 0, 0 and go till here. Okay. So pretty sure that this must be clear to each and every one of you. Pay attention. See, 1 plus 4, 5, 6, and then this is 11. Okay. So some other part will be there which we will be following. But the idea is, and I think it is this path. See, 1, 2, 3, 2, 3, and this. So something like the path which is getting followed, we have to see that. But each and every of these things, they are storing the answer, which or the minimum path through which we can reach out to this particular location. For this particular location, it is 1 plus 4, 5. Then we are taking this diagonal overall. Okay. So now we have this saved already. So of course, we will be not making those many calls. And we have also improved the complexity of our code a lot. So this is how, if we have multiple dependencies, we will be solving our question. Now, just one thing I want to make sure that you understand. So for that, again, we will do the same thing. Let me copy this whole code. And before we move on to the next approach, that is the tabulation approach. Let me edit this code. I want all of you to see that how exactly this is getting filled, because it is very important to understand how exactly this memoization is getting filled. Okay. If you understand that, then I'm pretty sure you will be able to understand how to write the tabulation approach as well. Many students, what they do, they just follow this particular memoization. They don't go deep into this. They just say that yes, my answer is getting saved, but how exactly is it filling? That thing is very important. Okay. So pay attention, everyone. Okay, we have some list like these. Should be fine. 1, 2, 3, 4, 8, 2. This is 1, 5, 3. Memo will also be created something like this only. So let it create. This is just range getting followed. Should be fine. Okay, so this is the memoization, everyone. Should be fine. Let us see. So these are my list. You can just think of this as your memoization metrics. Pay attention. So very first time our M and N is 2. So let me just draw on top of that as well. Right now, we are starting from this position. Okay. This is the position we are starting. It has dependencies here, here, and here. Pay attention on what exactly are we making the call. Okay. So see everyone. Let me just remove the drawings. Just follow this M and N call and you will get an idea. I want to show you that how exactly this memoization array or list will fill, because then you will be clear that, okay, which overall node or which overall space has some dependency. Okay, so pay attention. We will see that where exactly it starts getting filled. We can just till then make these calls. So if we are making a call to 2 1, then to 2 0. Okay, let us now move forward. This is 2 comma minus 1. So we will just get infinity here. Okay, then we are making a call to 1 comma 0. So 1 comma 0 here. It will make a further call. So calls are going to get made a lot. This is going to return infinity. Finally, you will see that 0 comma 0 we are making a call. Okay. Now just let me explain you here as well. If we see this particular thing, so that you are able to write the code for your tabulation approach as well. So pay attention, everyone. This is again our 2D space. Okay. Here we are starting from this particular space. I make a call to this, to this. Then this is going to make a call from this. It will get infinity. Okay. Then make a call to top. Then it makes another call here. It will get infinity. Finally, we will reach here. Now here, because this is a base case. Okay. Again, the thing to understand, this is a base case. Is a base case. We will have the answer here. We will have some answer here. We will go back and now it will try to make a call in the diagonal, which is infinity. The point which I want to make you understand is that these corner elements, they don't have any dependencies rather than just the top element. I hope this is clear as well, right? So what I'm saying is that just this answer, it doesn't have any dependency. It's a base case. This particular position, this particular box, it just depends on the top because the left and the diagonal both are overall not present. So the answer will be infinity from there. Same for this. Okay. In a very similar way, this particular box, just this is something which is present above and diagonally, we will get infinity. Okay. So based on this understanding, now you will have to write the tabulation code as well, right? Now many students, they face this difficulty because they don't understand that how this memoization array will fill. Because I have followed this approach from the start, that if you understand that how this memoization array will fill, you will be able to understand this properly, and no code for pure DP will be difficult for you. And I've shown you here as well that how exactly it is going to fill. Okay. So once we have everything filled here, then this will make a call to top. We have this answer. We have this answer. It will make a call to top. So like this, our whole space will get filled. And this is very important to understand again, so that you can write the memoization approach, tabulation approach, that is the pure DP solution. Okay. So I hope this idea is clear a little bit. In the Python tutor, it is getting a lot messy. So I want to make sure that you understand this particular point. Based on this understanding, you should be right. You should be comfortable to write your pure DP or tabulation approach. So please make sure that you try this out once. And in the next video, we will see that how exactly can we solve that. Okay.